All right. So the yesterday we talked about sigma notation, and you played around with it, and then I gave you these handful of problems. Get an answer, and then like 7 through 12, put it in summation. Okay, big deal. And then the last two problems, it says use the summation formulas to find the answer. Well, to be honest, to use the summation formulas is a royal pain, right? I am going to use the summation formulas, right? To be honest, you've got 7 things, right? Wouldn't it be just pretty easy to plug in a 1, get a number, plug in a 2, get a number, plug in a 3, all the way up to plug in a 7, get a number added up? Or if you just wanted to get an answer, there is a summation feature on your calculator, and it looks exactly like this. So you type it in exactly like this, boom, you get an answer. I don't care about the answer, right? I care about this, because this actually has some meaning that I hope I get to today. Now, so how do you use those formulas to answer this question? Well, to use these formulas, you need to see the sum from I equals 1 to some number of I. You just got to have an I, or you just have an I of an I squared, right? So what do? Well, first, with summations, kind of like derivatives, think numbers that are being multiplied or decoration, I can put those out here. Right? Those have 0 impact on the actual summation. So what I can do is take that 2 over 7, and I can put the 2 over 7 out here, and then I have this. Okay, I've got this thing left. So I've got this summation from I equals 1 to 7 of this thing, all right? I'm going to try to save a little bit of space. Oh, shoot, that's not... Okay. I can't handle this. I can't handle something squared, so I have to multiply it out. And so to multiply this out, it's just a binomial. You square this, you get a 1. Right? You square this at the end, we're going to get a 4 over 7 I squared. The thing in the middle, multiply these together, multiply it by 2, and so this is going to give me 2 times 2 over 7I.
So can you just make that 4 over 7I?
What? Oh, it's 4 over 49.
I'm saying can you make it 2 times?
Oh, 4 over 7, yes. Now, I know will in just a second. All right, are we okay with this? And again, I still can't handle it because I don't see like summation of I, right? I got jump next to it, right? Well, I glossed over this yesterday, but if you're summing up a bunch of things, that's actually the sum of those individual. And so what this ends up being is, I get my 2 over 7 times the summation from I equals 1 to 7 of 1, plus 4 over 7 plus the summation from I equals 1 to 7 of 4 over 7I, plus the summation from I equals 1 to 7 of 4 over 49I squared. You see what I did there? Are we okay with that part? Now, just like I remember with summations, a number that's multiplied, you can put it in front. So I'm going to take that 4 over 7 and put it in front. I'm going to take that 4 over 49 and put it in front. Okay. Don't worry, I'm going to write it over here. Okay. And when I do that, let's see, I get a 2 over 7. And this gives me the summation from I equals 1 to 7 of 1, plus 4 over 7, summation from I equals 1 to 7 of I, plus 4 over 49 times the summation from I equals 1 to 7 of I squared. Okay, so all I did was take these numbers out. Why did I do that? Well, now I have something I can use. Can I use a formula to figure that part out? Can I use a formula to figure that part out? Can you already see that? And so now I end up with, okay, this is 2 over 7. All right, this. Well, if I goes from 1 to 7 of 1, that's going to be 1 7 times. Are we okay that that's going to be the number 1 times 7? Plus 4 over 7. To plug this in my lovely little formula, I'm going to 7, so this is going to be 7 times 7 plus 1 all over 2. And then I get plus 4 over 49, and that goes here, which is, I need a bigger board, all right? I need to erase this. So I get 7 times 7 plus 1 times 2, 2 times 7 plus 1, all over 6. All right. Okay, so I'm not going to make you do this. All right? If we had the time, probably would. We don't. Right? Is the AP exam going to make you do this? No. Right? But they're going to ask questions that assume that you have done it at some point. Right? And so what I'm trying to do is do a nice little shortcut where we're going to talk about the important aspects of this without physically going through the pain and suffering of it. All right? So everybody kind of see where we're going with it now. Okay. So can we kind of agree that if I were to type this giant mess into my calculator, I would get the final answer, I would get the right answer? Is this the most efficient way to add up from 1 to 7? Oh, no. It would be so much easier just plug in 1, 2, 3, 4, 5, 6, 7 and be done, right? But what if it was to the 700, right? Well, if I wanted to add up from 1 to 700, now these formulas look kind of reasonable, don't they? What would I have to do? Just change all the 7s to 700, right? Right? And then the amount of work that you do is not, it's almost like computing summing up from 1 to 700 isn't that much harder than computing from 1 to 7, right? Does that kind of make sense? Right? And so we got this giant mess. Yay. Right? I am going to come back to this, so if you haven't written this down, please have this written down because hopefully I'll be able to refer back to it, if not today, tomorrow. And if I could use the entire board, for those of you virtual, I literally am only using about half of my board. I have like 3 feet on this side and probably another like 5 feet on this side. And so I'm having to squish everything. All right. Done. All right, done with this ugly thing for now. So today, we get to ask the important question of the semester. Right? The important idea of last semester is what's the slope of the tangent line. Right? We answered the question, what's the slope of the tangent line, and we got this derivative thing, and there were all these applications. Right? The question for this semester is, what's the area under the curve? That's the question. I want to know the area under a curve. Right? And somehow that has significance. Right? You don't know what that is yet, and I'm going to talk about it later, but that's the big question. Right? Last semester, the big question was, what's the slope of the tangent line? This semester, the question is, what's the area under the curve? Well, so first we're going to practice finding the area under the curve. Well, there are certain curves that are very easy to find the area of. If I give you y is equal to 2x, and I'm interested in the interval from 0 to 1, this is incredibly easy. Just draw a picture. Don't write this down. Right? You just draw a picture. Everybody knows what the line y equals 2x looks like. Boom, right? If I'm going from 0 to 1, this is of height 2, this is height 1, What's the area under the curve, the area between the curve and the x-axis? Well, that's just a triangle, right? 1 times 2 divided by 2, right here. We're done, right? Zero work, right? We know the area under, in math speak, any graph is a curve. So even though it's not curved, right? What's the graph under that function? Well, it's kind of silly, right? It's just a triangle. But what if I give you y is equal to x squared, and I'm interested in the interval from 0 to 2? So if I give you y equals x squared, and I'm interested in the interval from 0 to 2, well, you know, that, you didn't learn how to do that in geometry. You know, here's 0, here's 2. I want to know this area, right? Yes?
Is it only the positive, like the first quadrant?
I mean, I could do stuff from over this side. Like, I'm going from 0 to 2.
Yeah, but like, so 0 to 2, but there's no like y and like restriction, so why isn't it going down like to the negative y?
Oh, go in, between the x-axis. I want the area between the graph and the x-axis. And we are going to learn about some things that if it's above the x-axis, we're going to get a positive number. If it's below the x-axis, we're going to get negative numbers. But that's later. Let's just deal with finding this area, right? And am I correct in assuming that you didn't learn how to do that in geometry, right? Right. We know how to do circles and other stuff, but we don't know how to find the area under a parabola, do we? Well, right now we don't either. So what you do, one thing you do in math when you don't know how to find the exact area, you say, well, can I approximate it, right? And the way we're going to approximate, there's a couple of ways we approximate, but today and for the near future, first I'm going to use 4 rectangles. And so if I use 4 rectangles, well, let's see. We divide this up into 4 parts. And we get a rectangle here, a rectangle here, a rectangle here, and a rectangle here. And if I were to find the area of each of these 4 rectangles and add it up, could that be an approximation for the actual area? Is it the exact area? No, right? Is it an overestimate or underestimate?
Over.
Over, right? Silly questions, okay? Yeah, so silly questions, and I don't know where I'm going with this, but I like making a chart. And so when I make a chart, like I want to add up those 4 rectangles, and the way I deal with this is, you know, I make up a chart. Each rectangle has a base, and it's got a height. And it's got an area. Yes, you want to do this. I gave you some homework problems, so I guess I'll model what you're doing in homework problems. So this is rectangle 1, this is rectangle 2, rectangle 3, and rectangle 4. All right, I'll fill this column in a little bit. All right, what's the base of this rectangle? 0.5, how'd you get that? Because you said 2 divided by 4, right? Is everybody okay? The base of this rectangle is 1/2? So the base of this rectangle is 1. Actually, while we're at it, what's the base of the second rectangle?
1.
All 0.5.
They're all 1/2, right?
Yeah.
Everybody okay? They're all 1/2? Okay, so this is all 1/2. Okay. So far, so good? All right, height. So here's my rectangle, right? And you know, the way we're going to get our height is we have to plug whatever this x value is into the function. I'm going to call this x sub 1, I'm going to call this x sub 2, I'm going to call this x sub 3, I'm going to call that x sub 4, right? And the way you get a height is you plug this into the function, right? Whatever value this is, we're going to plug into the function. Well, what's the x value here?
0.5.
1/2. And when I plug that into my function, what do I get?
0.5.
1/2 squared, right? And so this gives us 1/2 squared. Is everybody okay with that? And so the area of this rectangle is 1/2 times 1/2 squared. Okay. Yeah, I found the area of one rectangle, all right? Okay, let's find the area of the second rectangle. All right, we already know the base is 1/2, all right? To get the height, I have to plug this x value in. What is this x value? 1, right? Okay, half, we got 1, right? So this is 1, and I plug it into my function, this is going to give me 1 squared, right? So if I want this area, well, this times this, so I get 1/2 times 1 squared. All right. The base is still 1/2. What's this x value? 1.5. I'm going to write that as 3/2. Okay? And when I plug that in, that's going to give me 3/2 squared, right? And so my area is going to be this times this, which is 1/2 times 3/2 squared. Just write down my chart of my rectangles. And to get my height here, what's my x value? 2, right? It's right at the end, okay? And so that's 2 squared, and so I end up with 1/2 times 2 squared. I don't see a pattern with it looking like this, right? And since I don't see a pattern, I'm going to change some things. Instead of saying 1, could I say that's 2/2? Is everybody okay with that? So instead of saying 1, I'll say that's 2/2, and that's 2/2. And also, instead of saying 2, I'm going to say that's 4/2. So far, so good? And what I want to do is, that's the area of the first rectangle, second rectangle, third rectangle, fourth rectangle. I'm going to write those out. So the first rectangle is 1/2 times 1/2 squared. The second rectangle is 1/2 times 2/2 squared. The third rectangle is 1/2 times 3/2 squared. And the fourth rectangle is 1/2 times 4/2 squared. Did that fit in? Almost. Okay. Now, these are almost the same, aren't they? Can you think of like each of our rectangles are almost the same? I would like to write this in summation notation. Just trying to connect with what we did yesterday. All right, summation notation. Let's do the easy part first. I was going to go from 1 to what? How many rectangles you got?
4.
We're going to count from 1 to 4, right? Does that make sense? All right. Now, the trick to writing this in summation notation is you look at this and you write down everything that's exactly the same from term to term. What does each of those terms have?
1/2 and then 2.
Each one has a 1/2, right?
1/2 squared.
It's got a something squared, right? And you were saying it's divided by 2. And so what needs to go here? An I. Does that make sense? And if you look at it, you can almost see the base times height. Can you see it? Can you see this is the base of each rectangle? This is the height, right? And as you look at this, I want you to think, oh, well, the base is always the same, which is why that's always 1/2. And the height is you plug something into this x squared. Does that make sense? All right? All right? All right. Now, what changes if instead of wanting 4 rectangles, what if I want 7? So I'll go ahead and say this is when n equals 4. 5, 6, and 7. I'll probably need to draw a new picture. And can we agree that if I did 7 rectangles, that would be a more accurate answer? the more rectangles we have, we're gonna have more accurate answers. So, you know, I have, here's 2, and then I'll have, yeah, we've got 6, you've got my 7 rectangles, okay? All right. What's the base?
1 over 2, 2 over 7.
What?
2 over 7.
2 over 7. Total distance divided by width, okay? Are we okay that each width is 2 over 7? So the base is going to be 2 over 7. Oh, I guess I should go ahead and say, well, that was going to be 2 7s, that was going to be 2 7s, that's going to be 2 7s, dot, 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 right? Now, let's figure out the height. How do we get our height of the first rectangle? Plug in 2 over 7, right?
449.
I don't care, I want 2 over 7.
2 over 7.
Okay. We're okay? And so this is 2 over 7, and so this is going to give me 2 over 7 times 2 over 7 squared. All right, fine. Well, how do we get the next height?
4 over 7.
4 over 7. How about we think of this as 2 over 7 times 2? How do we find the height of the third rectangle?
2 over 7 times 3.
2 over 7 times 3. Do we see a pattern? Okay, so this is going to give me 2 over 7. That's going to give me 2 over 7 times 2 squared. This is going to give me 2 over 7 times 2 over 7 times 3 squared, right? Everybody okay? We're going to get 2 over 7 times 4? Oh, I guess I need to tell you about this mysterious column that I put in. A lot of times when you're doing this, they'll say, what x value are you plugging in? And for this one, this x value is just 2 over 7 times 1. We plug this x value in, which is 2 over 7 times 2. And this was going to be 2 over 7 times 3. Like that x is like, what physical x value are you plugging in? All right. Now, can I write the summation? Because it's going to be this plus this plus this plus this plus this all the way to 7, right? So if I want 7 rectangles, right? I is going to count from 1 to 7. What goes here? What's your base?
2 over 7.
2 over 7. What goes in the parentheses?
2 over 7 times 5.
Perfect. Does that make sense? And this is for 7 rectangles. Have I lost anybody? Yes.
So for the last equation, could you have also just gone 1 over 2 times I?
Yes.
Okay.
Yeah. All right. Are we okay with this? Don't worry. We're going to practice this a bit, right? The idea of going from here to here is huge. This is a big deal in the AP exam. If their goal is to find the area. Well, I think we can agree that that's more accurate, but what would I need to do to get even more accurate?
Make it really, really big.
Make it really, really big, right? Like I'd have to plug in like 700, right? Well, actually, I'm writing stuff over here. Didn't mean to erase that. I needed y equals x squared from 0 to 2. This is our lovely interval, and I just don't have room for the picture. What would it look like if I wanted n rectangles? So if I wanted 7 rectangles, I'd put 7 in all those places, right? If I wanted n rectangles, what would it look like? I want n rectangles, count from 1 to what? N. What goes here? 2 over n. What? 2 over n I squared. Do you see I just simply changed all the 7's to n's? Now what's the significance of having n rectangles? Right? I mean, actually it's kind of neat, right? If I want to know, well, what's my area, how can I approximate the area if I wanted 100? Well, I just replace the n with 100, right? What if I want 1,000? I replace the n with 1,000, right? What if I wanted the exact area? How many rectangles would we need?
Infinite.
Does that make sense? If I wanted the exact area, then I would need an infinite number of rectangles. Does that make sense? Huh. So what does that look like? Well, believe it or not, we can compute this. All right? And it's not as ugly as you might think. Okay? I'm going to have some room over here. I'm going to write this as so this is going to be the limit as n gets really big from I equals 1 to n. I'll square this, so I end up with 2 over n times 4 over n squared times I squared. Now you haven't done many of these, so I'm going to do this, and don't worry, you're not going to have to do any of these either. I just need to do this one, right? In computing summations, the only letter that counts is what's here. That I is what counts. This n is basically a constant. And because that's a constant, I'm going to pull that out. And so this is going to equal the limit as n goes to infinity. When I pull this out, I end up with 8 over n cubed times the summation of I equals 1 to n of I squared. And now, that looks like a formula we've seen. And I'm going to write it over here. This is going to be the limit as n gets really big of 8 over n cubed times that formula which I had written, n times n plus 1 times 2n plus 1 all over 6. So I did all this work to get here, but I can compute that limit. Anytime you have a fraction, you think, is it top heavy, bottom heavy, or balanced? Turns out this is balanced. Like if you were to multiply these out, you'd get like an n cubed on top and you have an n cubed on the bottom. Turns out when you simplify this, let's see, 2 goes into this 3 times, 2 goes into this 4 times. When you multiply this top part out, you're going to get an 8n cubed over 3n cubed. And the n cubes cancel out, so we're going to end up with this as 8 over 3. Don't worry, I just threw probably the most algebra at you that you've ever seen in a day. I'm not expecting to absorb all of this. I'm just sort of saying we computed this. Here's the significance of that. What we just found out was in a parabola from 0 to 2, this area is 8 over 3. That's the exact area. Yes?
Why is it 4 over 3?
There's a 2 here.
Oh, yeah.
Right? Which is kind of neat. All right. We're going to be playing around with this a bit more tomorrow. Couldn't have enough time to actually spend time doing this. All right. So I'm not really I already had this on the board. I talked about finding the exact area. I wanted to do it once. We'll do it again later. But now I want to revisit this problem. I still like y equals x squared, but now I'm interested in the interval 1 to 3. And I want 7 rectangles. Let's see what that picture looks like. So here's our parabola. But now we're going from 1 to 3, right? And I want 7 rectangles. I can do a better job drawing that. And I want my 7 rectangles. And let's see, I got a base and a height, and here's rectangle 1, 2, 3, 4, 5, 6, 7. All right, so let's figure out what we know. Technically, that's the x. I need to write that down. I'm putting it down because I stuck it in your homework. What's the base of each rectangle?
2/7.
What?
2/7.
Everybody okay with 2/7? So whatever this is divided by 7? And so the base of each rectangle is 2/7. My claim is after the third rectangle, we'll know what the pattern is. Okay? Okay, now here's the hard part. What's the height? What's the height of the first rectangle? We plug this value into the function, right? What is this x value?
9/7.
What?
1 plus 2 over 7?
Yeah, that's the same thing, but your life's going to be easier if you write it as 1 plus 2/7. Are we okay with that? Because it's 1 and we know that's 2/7. So we know this is going to be 1 plus 2/7, which means this is 1 plus 2/7 squared, right? All right?
Yes. Why is it 2/7 and not 3/7?
What's this total distance?
Oh, it's 1 to 3. I thought it's
Yeah,
0.
yeah. Okay. What's this value we're going to plug in?
2 plus 2 over 2 times 2 over 7.
There you go. 1 plus 2/7 times 2. Right? Everybody see that? Guess what this one's going to be?
1 plus 2/7 times 3.
1 plus 2/7 times 3, right? Remember I said by the third one, I think we should know the pattern? All right, here's your challenge. Everybody write the summation for these 7 rectangles. You got your base, you got your pattern for the height. I want everyone to write down the summation. The summation from I equals 1 to 7. Write it. Do you notice anything? What do you notice?
It's the question from the
It's that first question I did in class. Do you see it? Okay. So when you write this, you've got a base, which is 2/7. Your height is 1 plus 2/7i squared, isn't it? And that was the exact same thing that we had at the beginning of class. Meaning, Remember that one big ugly thing where I had a bunch of n, where I had 700 and I made it a bunch of n's at the end? If I did limit as n goes to infinity of that big ugly mess, what would we have found? That area. Does that make sense? Because I went through and like I changed all of that